Okay, next method is Kelly's measure of skewness. So here the Kelly's measure of skewness formula is P90 percentile 90 minus 2P, P50 minus P plus P10 by P90 minus P10. P is nothing but 90th percentile, 10th percentile, 50th percentile. This 50th percentile is nothing but the median class. So here with the help of the percentiles we can identify, we can measure this Kelly's measure of skewness. That is the coefficient of skewness with the help of Kelly. So here we have taken the example class interval frequency, cumulative frequency. So to find out this Kelly's measure of frequency P90, P50, P10, P90, P10 we have to calculate. For this purpose we have to take the class interval. Similarly as usual in the previous example, frequency and cumulative frequency. 10 to 20, 18, cumulative frequency 18, 20 to 30, 30 frequency, cumulative 48, 30 to 40, 40 frequency, cumulative frequency 88, 40 to 50, 55 frequency, cumulative frequency 143, 50 to 60, frequency 38, cumulative frequency 181, 60 to 70, frequency 20, cumulative 201, 70 to 82 class interval, frequency 16, and cumulative frequency 217. So here, first we have to calculate the P10 because here we need P90, P50, P10. So to calculate this percentile 10, the formula will be L1 plus L2 minus L1 by F1 into M minus. Here we have to calculate that M item, the class item, median class item, N plus 1 by 10 means P10 means 10th percentile. We have to calculate N plus 1 by 10th item. That is 217. That is total number of items that is equals to N. N this N plus 1, 217 plus 1 by 10. That is 288 by 10. That is 21.8. Means in which median class this 21.8 is existing here. This cumulative frequency we have to check 18 and afterwards 48. So this in this class, this P10 will be existing first percentile, 10th percentile. So here we have to consider this median class for this purpose, that P10 is equals to L1 lower region 20 plus 30 minus 20 means upper limit of this class interval minus lower limit of the class interval by the corresponding frequency of this corresponding median class, that is 30, 20 minus 20 by 30, then into M minus C. M is equals to, already we know that N plus 1 by 10th item, that is 21.8 minus 18. How much it is? 18 is the frequency, the cumulative frequency which is preceding the median class. This is the median class. This median class is preceded by this cumulative frequency 18. So 18. The total P10 is equals to 21.27. So by calculating these values, we'll get 21.27. Then afterwards, we need P50. P50 that is equals to median. Of course, it is the median. So P50 is equals to P217 plus 1 by 2. Okay. So here 218 by 2th item, that is 109th item, we have to take it as a consideration. So 109 means here we have to check the cumulative frequency 18, 48, 98, 109 means in this median class, this P50 percentile 50 will be existing. P50 will be existing in this median class. So here we have to take that median class is into the consideration and we have to substitute those values in this form. That is P50 is equals to how much it is? 40. Lower limit of the interval 40 plus L2 minus L1. Upper limit of the interval 50 minus lower limit of the interval 40 by the corresponding frequency of the median class, that is 55 into 109th item, that is 109 minus the cumulative frequency which is preceding the median class, that is 88. 109 minus 88, that is 43.8. Then that is P50 is equals to 43.8. Then coming to P90. P90 means here we have to take 90 into 217 plus 1 by 100th item. Means the particular 98th item we have to get. Particular 98th item we have to get. What we have to do? We have to make it as 100 parts. Means total is nothing but 100%. So 217 plus 1. How much it is? 218 by 100%. 218 by 100 into 90th item we have to take. That's why 196.2th item we have to consider. 196.2 means 181. This is 196.2. That is 60 to 70 class. We will get the P90th item. P90. So here P90 is equals to 60. That is lower limit of the interval plus 70 minus 60, upper limit of the interval minus lower limit of the interval by corresponding frequency of this class, median class, that is equals to 20. Then 196.2 minus the frequency, cumulative frequency, which is preceding the P50, P90th median class, that is 181. So 181, okay, 196.2 minus 181. So here total 67.6 we will get. Then by means here we have P90, P50, P10. So all these values, what is P10 here? 21.27. Then P50, 43.82. And P90, how much it is? 67.6. So what is the formula for us? Coefficient of skewness with SKK is equals to P90 minus 2 P50 plus P10 by P90 minus P10. Then here we need to substitute. So P90 is equals to how much it is? P90, 67.6 minus 2 into P50. What is the P50? 43.8 plus P10. P10 how much it is? P10 we got it at 21.27. So by P90 minus P10, 67.6 minus 21.27. Then to simplify this value, we'll get 0.027. That is positively skewness we will get here with the help of Kelly's measure of skewness. Doing this skewness. So already we discussed about measurement of skewness. Here skewness means how the variation of that particular distribution from the mean. So that is how the distribution will be. Is it in the normal distribution or positively skewed or negatively skewed? So how that frequency curve should be, how it is skewed means already we discussed from the various measures, Kelly measure, Bowley's measure and Carl Pearson measure of skewness. So here one more concept related to that skewness, that is kurtosis. What is that? This is another measure of the shape of the frequency curve. So it is also how the skewed, how much skewed we got either positively or negatively skewed the distribution, we got it from the skewness from various measures. So here in the kurtosis, it is also one of the measure to find out the curve nature of the frequency distribution. So how the frequency is distributed, how it may be distributed like this, it may be distribution like this, it may be distributed like this, like this. So what is the distribution of this frequency? So here we are going to discuss in the kurtosis. So that is, it is also one of the measure of the shape of the frequency curve. So it is going to identify the curve shape, how it is, what is the nature of that curve. We are going to identify with the help of this kurtosis cards. And next point, that is, it signifies extent of asymmetry. So if it is symmetrical curve or asymmetrical curve. So if it is asymmetry, how extent it is asymmetry. So what is the nature of that particular curve we are going to identify, we are going to measure that asymmetry of that curve. So that is the second point. This is that first of all we are going to identify the we are going to measure the sheaf frequency curve with the kurtosis method, and also how extent it is asymmetrical. Okay, if it is not symmetrical, how extent it is asymmetry, we are going to the degree of asymmetry we are going to identify from this kurtosis concept. Next, it measures degrees of peakedness of the frequency curve. So it is clearly measured how much the frequency curve is peaked, means what is the mode of that particular frequency curve. So if it is in the normal distribution or not in the normal distribution, if it is the normal distribution, how much it is peaked. So how much it is peaked, like this or like this or like this, means how much it is peaked, the peakedness of this curve we are going to identify with this kurtosis concept. Okay, so that is here, that is the purpose we are going to measure that frequency curve with the help of kurtosis concept. Okay, next types. Here we have to identify, we are going to measure with the help of three types of kurtosis method. Here, what are those three types here? Three types on the basis of the shape of the peakedness. So how much that peakedness means, all the distribution may not be same curve. So different distributions will give different frequency distribution curves. It may be some distribution curves may be very much peaked, some frequency distribution curves are less peaked, some frequency distribution curves may be flatter with that axis like that. So according to that peakedness of the curve, so we are dividing that kurtosis into three types. So what is the three types of the kurtosis? First one is mesokurtosis. Mesokurtosis means this mesokurtosis almost all, I didn't means almost all making a normal distribution curve. When the frequency distribution is making it normal distribution curve, it called as mesokurtosis. Means it is nothing but almost all, it is making the normal distribution. Then second one is leptokurtosis. Leptokurtosis is nothing but most peaked. It is very much peaked than the normal distribution. So that is leptokurtosis. Next one is platykurtosis. Platykurtosis is nothing but almost all flatter with the axis. So it is very much flat. It is very much flat curve. Here first normal distribution curve, that is mesokurtosis. Second one is leptokurtosis, is nothing but very much peaked curve we were identified. And in that platykurtosis is nothing but very much flat curve with the axis. So almost all these three frequencies are nothing but, so if if that curve identify means if curves follows that normal distribution is called mesokurtosis. If it is more than the normal distribution, we can call it as a leptokurtosis. If it is less than the normal distribution curve, it is called as a platykurtosis. So now we are going to discuss about this kurtosis in graphical model. The help of graph we are going to discuss. So now we can see it as a graphical representation of this kurtosis concept. So here, first of all, what is the coefficient of kurtosis? Here we have the coefficient of kurtosis is given by the Carl Pearson, that is beta 2 is equals to mu 4 minus mu 2 whole square, means mu 4 minus mu 2 square is it is the coefficient of kurtosis from given by that Carl Pearson. So here in normal distribution, if that frequency distribution follows the normal distribution, we will get that beta 2 is equals to 3. Then if the beta 2 more than 3, the curve is called leptokurtosis. Leptokurtosis means, which is here we can see that graphical presentation, when we have this curve in more than, means like we have highest mode this in this, this is nothing but leptokurtosis. Okay. Then when it follows the normal distribution, it is nothing but, what is that? Mesokurtosis. Means a normal distribution is called, also it is called mesokurtosis. So when it is following the normal distribution, it is called mesokurtosis, and when it is having the peakedness of the curve is called the leptokurtosis, and which when the curve is almost or flattered to the with the x-axis is called platykurtosis. So here platy, meso, lepto. Lepto is if the coefficient of kurtosis is beta 2 is equals to mu 4 by mu 2 square, then in normal distribution beta 2 is taking the value of 3. If we are getting the beta 2 is equals to 3, it is called, what is that? Mesokurtosis, or nothing but normal distribution. It is following the normal distribution. Next, if the beta 2 is more than 3, okay, so that more than 3 is called, if it is 3, it is nothing but mesokurtosis. If it is more than 3, it is nothing but leptokurtosis. If it is less than 3, beta 2 is equals to less than 3, it is nothing but, what is that? Platykurtosis. So for that purpose, here to identify the kurtosis, mean is the perfect measure for, mean is perfect measure for mesokurtosis. Mesokurtosis. And next here, why? Because mean will be is equals to normal distribution follows this mean. So mean is the perfect measure for mesokurtosis, and mode is the perfect measure for leptokurtosis. Why? Because here we have the highest mode in the leptokurtosis. It is very much peaked. Because of this mode is the, what is that? Perfect measure for leptokurtosis. Similarly, platykurtosis is nothing but quartile deviation is nothing but, quartile deviation is perfect measure for, what is that? Quartile deviation. Quartile deviation is perfect measure for platykurtosis. Platykurtosis. So So this is the concept of kurtosis. Here, when the kurtosis coefficient of kurtosis is Carl Pearson given by this coefficient of kurtosis is beta 2 is equals to mu 4 by mu 2 square. In normal distribution, that beta 2 is taking the is equal to 3 value. If it is in the normal distribution, is called mesokurtosis. Okay. Next, the frequency distribution beta 2 is taking the more than 3, it is called leptokurtosis, and beta 2 is less than 3, it is called platykurtosis. Graphically, we can show this. This is highest image which have the curve has most peakedness is nothing but leptokurtosis. A curve has following the normal distribution is called mesokurtosis, and a curve has very much flatter with the axis is nothing but the platykurtosis. So mesokurtosis beta 2 is equals to 3, leptokurtosis beta 2 greater than 3, and platykurtosis beta 2 will be less than 3. So next, mean is the perfect measure of means mesokurtosis or normal distribution, and mode is the perfect measure of leptokurtosis, and quartile deviation is the perfect measure of platykurtosis. Okay. Next, we are going to discuss the example.